So let's do a little bit of explanation about how these vectors work. I want to make sure that you understand that. And in this problem it says the magnitude of vectors u and v and the angle theta between the vectors are given. Find the resultant, and the resultant means the addition of the two vectors. Give the magnitude to the nearest tenth and give the direction by specifying to the nearest degree the angle that the resultant makes with u. So this is saying that in this particular problem they're going to give you the magnitude of two vectors and they're going to give you the angle between them, and they actually want you to find the resultant. So they want you to add the two vectors and they want you to find the angle that u makes with that resultant. So let me give you two of them. So let's say I gave you the magnitude of, let's go to this one. So let's see, here is the magnitude of vector u. And those look like absolute value symbols, but they represent the magnitude of that vector. And here is magnitude of vector v. And then theta is the angle between them. And there's two different ways to look at this. I actually prefer what's called the parallelogram method, and because that helps a little bit with some different properties that parallelograms have. It helps you with the angles. So what I tend to do is I draw each vector and I put them tail to tail is what I do. And of course we don't know some of the properties here, but we know the magnitude of each of those vectors and we know the resultant. And in the parallelogram method, the resultant, which is the addition of those two vectors, is represented by this ray here in the middle. So this is the addition of those two vectors, and the thing is it's not 54 plus 43. It is the length of this ray, and you can see we have some of these properties that we've learned from these triangles. This is the angle between them, and in parallelograms, this angle and this angle both add up to 180 degrees. This angle and this angle add up to 180 degrees. So you have different properties that will help you with this. The other thing that's the same in parallelograms is that the sides that are opposite are the same length.
I'm here, what you doing?
So when you look at those, you can use these properties that you have to find these answers. We're trying to find the length of this ray, which will end up being the addition of the two vectors. And we can use our law of cosines with this angle to find that side. So x squared would be 43 squared plus 54 squared minus 2 times 43 times 54 times cosine of 30 degrees. And when I take the square root of both sides of those, I get that x is approximately 27.2. And so that's the resultant. So that is u plus v is equal to 27.2. That is the addition of those two vectors. So that's the magnitude of that resultant is what that is. I hope that that makes sense to you. That's the size of that line is what you're doing. So you are finding the magnitude of that resultant that's there. Now, the other way that you can look at this is by using triangles, but let's finish this problem first. It asks you to find the measure of the angle between u and the resultant. So that would be this angle in here, this little bitty one here, which is not 150 degrees because that's this whole thing here together. So now that I know x, I can use the law of cosines again, and I can use this side of that triangle, which is 43 squared equals 54 squared plus 27.2 minus 2 times 54 times 27.2 times cosine, and I've called this alpha. And when you do your math by bringing the 54 squared and the 27 squared and dividing by this and hitting inverse cosine of that value, you get that the angle is approximately 52 degrees. So that's the angle between those two things. Now, if we look at it through using triangles, and keep in mind this is the drawing that we had before. So we had 54, 43, and we knew that this angle was 150 degrees. When you add them using triangles, you have to put them, I like to call it head to toe, but you put the initial value of 1 and you put the two together that way. See, ours were drawn with these initial values together. When you draw them with the triangles, you have to put the two together this way, so those heads are facing each other. So if we do that, we're really moving this up. So this is 54, this is 43, and the magnitude of the resultant then is this. And you can see that shape up in the graph that you have above it. So when we do that, since this angle was 150, that makes this angle up here 30 degrees. And so the math works the same. When you start trying to find the measure of the resultant, you're using your law of cosines, but you're not using 150 degrees like they give you. You are using 30 degrees. And so sometimes that gets a little confusing as to which angle you're supposed to use, because when they say the angle between them, people want to put this as the angle between them when you're really talking about this angle. So you have to be really careful when you're doing that. So again, that resultant comes out to roughly 27.2, and when we ask for the angle between you and the resultant, we're talking about this one, which was the same angle that we were looking at before, and we can do the same math that we had before, and we still come up with alpha is approximately 52 degrees. But that's how that works. That's how the addition works for that. You have those two methods. You have the parallelogram method and the triangle method, and the parallelogram method will probably be easier for you to see the angles that are there. Let me draw it out one more time so you can see it. If you have two vectors that you're trying to find the resultant for, you have the magnitude of the two vectors. So if I have the magnitude of one and I have the magnitude of another one, if I draw them so that these initial points are together, I can form a parallelogram out of it. The resultant, the magnitude of the resultant is this one. The angle between them is this one. These two angles add up to 180 degrees. These two sides are the same, and these two sides are the same. And that makes the math work out a little bit better.